Let us look at question number 56 now. Consider the following redox reaction in basic medium. So we have been given chromate ions react with thiosulfate ions to form CrOH whole 4 minus plus SO4 2 minus. So we have to comment on the amount of Na2CrO4 required to react with 45 ml of 0.2 molar Na2S2O3. Students, let us first figure out the N factor of the respective species. In the thiosulfate ion, each sulfur is present in a state of +2, whereas in the sulfate ion it is present in a state of +6. So per sulfur atom there is a loss of 4 electrons and there are 2 sulfur atoms present in this molecule. So it is going to have an N factor equal to 8. If we look at the chromium containing species now, in the chromate ion, chromium is present in a state of +6, whereas in the species on the right, it is present in a state of +3. So we have an N factor equal to 3. So let us now try and apply gram equivalent concept in this question. So MEQ of CrO4 2 minus should be equal to MEQ of S2O3 2 minus. Okay. So the information of Na2S2O3 is given to us. It is 45 into 0.2 into the N factor, which was equal to 8. And on the left hand side we had 0.1 molar. Let the volume be VML into the N factor, which is equal to 3. So we can solve this expression to get the value of V as equal to 240 ml. Okay. So the correct answer for this question is option 3. Moving on ahead to the next question. Question 57. A hydrocarbon which is virtually immiscible with water was steam distilled at a temperature of 95 degrees C when the atmospheric pressure was 720 torr. If the vapor pressure of pure water at this temperature is 600 torr, then calculate the molar mass of the hydrocarbon if the distillate contains 60% by weight of the hydrocarbon. So students, we know that for two immiscible liquids, the total pressure is given by PA0 plus PB0. Okay. So the total pressure at temperature of 95 degrees C is given to us as 720 torr. And the vapor pressure of pure water is 600 torr. So the vapor pressure of the hydrocarbon shall be equal to the difference between these two. So which shall be equal to 120 torr. Now it is further given to us that the distillate contains 60% by weight of the hydrocarbon. So it means that the composition of the vapors formed in the first solution will also be the same. It shall also contain 60% by weight of the hydrocarbon. Okay. And now from Dalton's law, we know that the pressure exerted is proportional to the moles of the species present. So we can say that P0 of the hydrocarbon upon P0 of H2O shall be equal to the moles of the hydrocarbon upon moles of H2O. So let us assume that the mass be 100 grams. So we have 60 upon its molar mass, which we have to find out. This will give us the number of moles of the hydrocarbon upon the mass of water, which is 40, upon its molar mass, which is 18. So this is the number of moles of water and this is the number of moles of the hydrocarbon present. And the value of P0 we have already calculated before. This value is 120. The value in the denominator is equal to 600. Okay. And this is equal to 6 by 4 into M by 18. Okay. So upon simplification, the value of M comes out to be equal to 135 gram. So the correct molar mass of the hydrocarbon in the question is given in option number 2. Let us look at question number 58 now. An aqueous solution of AgNO3 was electrolyzed using inert electrodes for a time interval of t seconds. The solution was then neutralized using 15 ml of 0.5 molar calcium hydroxide solution. what is the mass of Ag deposited at the cathode during the time interval of t seconds. So the molar mass of Ag has been given to us. So let us try and figure out the reactions happening at the cathode and at the anode. So at the cathode, Ag plus will consume an electron and convert into Ag solid, whereas at the anode, the oxidation of nitrate ions will not take place. Okay, it will be water which gets oxidized. So H2O will convert into O2 plus 2H plus 2 electrons. Okay, so from these two reactions, we can see that per mole of electron, we have 1 mole of H plus and we also have 1 mole of Ag which gets deposited. So 1 mole of electron corresponds to 1 mole of H plus, which also corresponds to 1 mole of Ag. So the information about H plus is given to us in the question in the form of calcium hydroxide, that the solution required this much amount of calcium hydroxide for complete neutralization. So from here, from this information, we can figure out the moles of H plus, and from that we can directly find out the moles and by extension the mass of the solid which gets deposited. Okay, so let us use the information given about CaOH whole twice. Okay. So it has 15 ml into 0.5 molar into its n factor is 2. So this shall be equal to the millimoles of H plus, and which shall also be equal to the millimoles of Ag which gets deposited. So this value on simplification comes out to be equal to 15 millimoles. So the mass of Ag which gets deposited is equal to 15 into 10 to the power minus 3 into 108, which on simplification gives us a value of 1.62 grams. So students, the answer which we have to mark for this question is option number 1. Let us look at the next question, question number 59. For a first order reaction A converting into products, the plot of minus dA by dt versus T is correctly represented. So students, minus dA by dt gives us the value of the rate, and which is equal to K into concentration of A. So we know that the concentration of A can be written as A naught into e to the power minus KT. So this term is a constant. So it can be written as some other constant K dash into e to the power minus KT. So if we draw the plot of minus dA by dt with respect to time, it is going to be decreasing exponentially. So exponential decrease is given in option 3, which is the correct answer for our question. Let us look at the next question, question number 60. The following graph represents the total energy of homonuclear diatomic systems A2, B2, C2 and D2 as a function of their internuclear distance. Okay. Based on the above graph, we have to select the correct statement. So let us look at the options. The molecule A2 is stable. Students, we know that this graph represents the variation of energy with the internuclear distance r. So the minima in this curve represents the bond energy, and the distance to which the minima occurs corresponds to the bond length between the two atoms. So the minima on y-axis gives us the bond energy, whereas the point corresponding to that minima on x-axis corresponds to the bond length. So if we try and write an order of the bond energy, we have B2 will be greater than D2, will be greater than C2, will be greater than A2. And if we talk about the bond length, there will not be a bond between A and A, and the bond length of B2 shall be greater than C2 shall be greater than D2. Okay. So now looking at the options, the molecule A2 is stable. The molecule A2 does not have an energy minima. It has a positive value of energy all throughout. So the bond is not formed at all. The molecule A2 does not exist. It is not stable. The correct order of bond length is B2 greater than D2. Student, this statement is correct. The correct order of bond length is B2 greater than D2. C2 has a greater bond dissociation energy than D2. C2 does not have a greater bond dissociation energy than D2. It is D2 which is more stable and has a greater bond dissociation energy. A2 has a greater bond dissociation energy than B2. There is no bond formed in A2. So this statement is also incorrect. So students, the correct option for this question is option number 2. So this is all for today, guys.